So now for our third type of factorization, our third technique of factorization is the factorization of trinomials. So we've done tons of examples on what trinomials are under the algebraic expressions course. I said that a trinomial basically has three terms, right? That are separated by a plus or minus sign. But the type of trinomial that we will be factorizing, and I want you to listen to this very, very carefully. The types of trinomials that we will be factorizing are those that have the highest degree of 2. So what does it mean to have the highest degree of 2? You see x cubed plus 2x plus 1 is a trinomial. But to have the highest degree of 2 means that the variable in the expression has the highest exponent of 2, and it goes in descending order after that. So it'll be x squared plus 2x plus 1. So the variable in the expression has the highest exponent of 2 and lower, right? Not 3, not 4, not 5. It has to be 2 and lower. That's what highest degree means. When I explain this factorization, I categorize it according to the leading coefficient. So what does the leading coefficient mean? The leading coefficient is the coefficient of the term with the highest degree. So if you look at this here, if you look at this example here, which is the examples that we will be working with, trinomials with the highest degree of 2, the leading coefficient is the coefficient in front of the variable that has the highest degree, right? So for example, 2x squared plus 3x plus 1, the leading coefficient is 2. 3x plus 4x squared plus 5, the leading coefficient is 4, right? So it's the coefficient in front of the variable with the highest degree, which will be 2. Then we could have minus x squared plus 2x plus 1. The leading coefficient is minus 1, right? The way I discuss factorization of trinomials will be according to the leading coefficient. So when the leading coefficient is 1, when the leading coefficient is greater than 1, like these examples here, and when the leading coefficient is minus 1, right? So these are, you basically apply yourself slightly different. The techniques are slightly different. And I created this distinction because when we work with negatives, a lot of students make mistakes, right? So before I continue, to give you a brief idea of what we've done so far, the first type of factorization was factoring by HCF. The second was difference of two squares. Now the third will be trinomials, right? When we worked with HCF, there could be unlimited terms in the expression. We can find an HCF between all of those terms and extract it as a factor and find them and keep the remainders in the bracket. With difference of two squares, we said that we must have two terms. Both those terms must be a perfect square, and they must be separated by a minus sign. Now for trinomials, we must have three terms. Right, watch here. We must have three terms, and the highest degree has to be 2. So it has to be x squared. So we'll only be working with x squared down. This is what I meant by a quadratic expression, a term that we will introduce next year. But for now, you just need to know that when you have a trinomial, if you have three terms and you see a variable that has a cube in it, then obviously you cannot solve that. So you have to see that there have to be three terms, and there has to be the highest exponent among those three terms have to be 2. I hope I stressed that enough. Right? So let's elaborate on these ideas. Given the trinomial in the form ax squared plus bx plus c, case 1. Now watch here. There's something that I need to stress here. You see what I said here? I said given a trinomial in the form ax squared plus bx plus c. If you was given a trinomial in the form bx plus c plus ax squared, although they are not different, you need to put it back into the standard form. Because in order for you to utilize all of the rules that I will discuss here, you need to put it into the standard form so that you can utilize this rule and you'll understand exactly how it applies. So please ensure that it is in the standard form. Right? You have a standard, you have to keep to that standard. Otherwise, all of the rules at below it, everything that we discuss thereafter will not apply. Right. So, case 1. If the leading coefficient is 1, the coefficient of the x squared term is 1, then we can apply these rules. So, in order for us to utilize the techniques that we talk about here in case 1, we need to have three terms. The highest degree of these three terms, degree of 2, and lastly, leading coefficient is equal to 1. In other words, what I'm saying is that a is equal to 1. Where's the a? There's the a here. The leading coefficient is 1. Understood? Right. The way I'm going to explain this is by giving you an example, factorizing that example, and we can draw some conclusions by looking at the product. Firstly, you can see that the product of the last terms in each binomial yields a constant. See, the product of 2 and the product of 3 gives you 6. That's the first thing that we can see. Then we can also see that the product of the outer and the inner term gives you the middle term. See, outer 3x plus 2x gives you the middle term, 5x. Right? So what we can say is, by looking at this, so, right, remember if you had two brackets, x plus 2, x plus 3, first, outer, inner, last. Right? Remember that from products. So if you look at this here, if I have to write this in a more generalized form, right? If I have to write this in a more generalized form, we can say that, so if you're given this trinomial, x squared plus bx plus c, and it factorizes in the form of x plus d, x plus e, then what we can say is, if you have to open this out, x times x is x squared, x times e is ex, d times x is dx, and d times e is de. Then you, in these two terms here, you have a common factor of x, so you can pull out that common factor here, and what remains? D plus e times x is the same thing as ex plus dx. Remember I said in maths, these equal to signs basically mean that whatever you have here is a re-expression of everything above. So if you look at this and you look at this, see, DE has to be the same as C, and D plus E has to be the same as B. They are exactly the same. So what we can draw a very important conclusion from this. The product of the outer terms of each of these binomials must give you the constant, but the sum of these terms must give you the middle term. Think about how brilliant that is. So the product of the outer terms must give you the constant, but the sum of those same two terms, right, the same two terms from the outer terms of each binomial must give you the middle term b. Okay, so you need to keep that at the back of your mind. So you can see I say we must find factors of the constants that when added together or subtracted from each other yields the middle term. So you have to find factors of the constant. See, finding factors is basically saying find two numbers that when multiplied together will give you that number, right? I know it's a bit complicated, so let's solve an example. Let's say that we are given x squared plus 5x plus 6. How would we solve this? Very simple. Your first step is to look at the last term. The last term is very important. Look at the last term. Find what two numbers that when multiplied together will give you the last term. So firstly, let's list out the factors. 1 times 6 and 2 times 3. Right? So now we have to find out the product of what two numbers will give you 6. We have already found out that. So now what we can write so far is we know that this is how the factorized form will look. So now we need to find out what numbers we are going to add in here. And those numbers are found by finding which two of these factors when added together will give you the middle term. So watch here. See, 6 plus 1 is what? 7. That won't work. But 2 plus 3 will work. So therefore I can say it'll be plus 2 plus 3. Now it's not as simple as I just showed you, right? Just listing the factors, checking which of the factors when added together will give you the middle term. Because it gets a bit more complicated. And the reason I say it gets a bit more complicated because when we start adding signs to this, let's say that we have x squared plus x minus 6. Right? So you got 6, 1 times 6, 2 times 3. Right? So if you're given this example here, you can see that, watch it. Can you see this last term is negative? So in order for you to get a negative, one term has to be positive and one term has to be negative. See these terms here, these outer terms? One of it has to be positive and one of it has to be negative. But at the same time, when you add that one positive and one negative term together, it has to give you the middle term. So this is why it gets a bit more tricky. I will give you rigid rules, but I'm trying to show you exactly why it gets tricky. So the way you do this is very simple. If you look at this example, if I look at 1 and 6, if I say plus 1 minus 6, what do you get? Plus 1 minus 6 is what? Minus 5. If I say minus 1 plus 6 is what? Plus 5. So that doesn't work. If I say minus 2 plus 3, minus 2 plus 3 is what? Plus 1. And that in fact works. So therefore it will be minus 2 plus 3. So most of you are probably wondering, why did I say minus and plus? The reason I said minus and plus is because I saw the last term was negative. So when you multiply these two terms, one has to be negative, one has to be positive, because the negative terms are positive equals to a negative, and a positive times a negative is equal to a negative. So basically what I did here was simply say that I know one term has to be positive and I know one term has to be negative, so I am testing. So I make the first term negative, the second term positive, then I swap it. I make the first term positive and the second term negative and check if it gives you the middle term when you add it together, right? So in a sense, what I'm saying is by making one positive and one negative, you already solve half the problem because you already know that the product will give you a -6. Then you have to solve the second part of the problem, which is focus on the middle term. So when you're solving trinomials when the leading coefficient is 1, you're only focusing on two things, the last term and the middle term. Now what I'm going to do is, I know this is very confusing. So what I'm going to do is I'm going to solve 4 different examples that you could possibly get. And then I'm going to give you rigid rules that you could follow to solve any question when the leading coefficient is 1. So let's watch it. These are the 4 examples. And this is how I broke it down. You see, the last term here is what? Positive. And the last terms here are negative. So what do we know when the last terms are positive? We know that when the last terms are positive, you have to either have both positives or you either have to have both negatives. When the last term is negative, as I just showed you, then one term has to be negative and one term has to be positive, or one term has to be positive and one term has to be negative. That's what we do know. So looking at this, let's list the factors of 8. So 8 is 1 times 8 or 2 times 4. So looking at x squared plus 9x plus 8, watch here. I know that this will be x and x. Then I have to ask myself, already listed the factors. I can already see that the last term is positive. I must either use a plus plus or a minus minus. But here's the fascinating part. Although I'm using a plus plus, and remember I just said that you have to focus on two things, the last term and the middle term. I can only use a plus plus. Why? Because the middle term is positive. The sum of 2 negatives will always give you a negative, and the sum of 2 positives will always give you a positive. Think about that, and you can write that down as a rule. So therefore, I know I'm going to take this option. So for this first one, I'm taking the plus plus option because, let me just write this here with the yellow marker for this example. I'll have to take the plus plus because we have the case where the last term is positive and the middle term is positive. So therefore, it'll be 2 positives. So it'll be plus 1 plus 8 gives you 9. So therefore, we already found the solution on the first try. Right? Sometimes you have to try it for the second set of factors. Let's look at the next example. X squared minus 6x plus 8. Okay, so the last term is positive. That's the first thing that you check. Then look at the middle term. The middle term is negative. So therefore, I cannot take the plus plus solution because it'll give me a positive. And when you add 2 positives together, it gives you a positive and not a negative. So therefore, I have to take the minus minus. So therefore, very simple. Check it. So therefore, you'll have x, and you'll have, see, minus 1 minus 8 is what? Minus 1 minus 8 is minus 9. But minus 2 and minus 4 is what? Minus 6. So therefore, on our second attempt, we were able to find the solution. So x minus 2, x minus 4. Very, very simple. Very, very simple. Now let's look at the case when we have the last term as negative. When you have the last term as negative, and this is going to require a bit of explanation. When the last term is negative, you either have to have 1 positive and 1 negative, or 1 negative and 1 positive. So what we know so far is we can write this here. X, and now we have to find the outer terms. Very simple. Right, so this is what we know so far. That the first terms in each bracket has to be x. Now let's find the second terms. And watch how brilliant this is. We know that the last term is negative, so one has to be positive, one has to be negative. The second clue is looking at the middle term. You see the middle term is what? Positive. So if the middle term is positive, when you're looking at your factors, the bigger number has to be positive and the smaller number has to be negative. Why? You have a lot of positives. You're adding that to a small amount of negatives. It will overall give you a positive. So what we can say is, I could say, if I'm looking at this factor here, where does the negative go and where does the positive go? The positive will go on the bigger number. We've already found out why. So you'll say negative 1 plus 8 is what? 7. And we found the answer on the first try. So it'll be negative 1 plus 8. Understood? So we already know that one has to be negative and one has to be positive. So we already found or solved half of the problem because we know the product will be a negative. The second half of the problem is finding the sum that will give you the middle term. So that is all you're doing with trinomials. You're focusing on the last term, you're focusing on the middle term. When you combine those ideas, you'll know exactly which term will take the positive and which term will take the negative. Very simple. Let's look at this one here. X. Now let's solve this. We have a negative. The last term is negative. So therefore, one has to be positive, one has to be negative. Half the problem is solved. Let's look at the middle term. The middle term is negative. So therefore, what we have to say is that the bigger term has to be negative, because a bigger amount of negatives added to a smaller amount of positives will give you what? A negative. So let's look at the first term. Remember, we said the bigger number has to be negative. Plus 1 minus 8 is what? Minus 7. Plus 2 minus 4 is what? Plus 2 minus 4 is what? Minus 2. So it'll be plus 2 minus 4. And that's how we solve it. So these are the ideas that you need to keep in mind. All you're doing is two things, right? When you're solving trinomials, you're doing two things. You're focusing on the last term and middle term. Very, very important. So if I have to write this as a set of rules, this is how we're going to do it. Firstly, you find factors of the last term. We've done that. Then you check the sign of the last term. We've done that. Last term is positive, last term is negative. If it's positive, then you're going to have the case where you'll have a plus plus or a minus minus, right? That's what your outer terms in the brackets have to be. If it's a negative, it has to be a minus plus, like here, or a plus minus, like here. Then you look at your middle term. Now this is, see, when you look at the middle term, you have to keep both ideas in mind. You have to keep the last term in mind and the middle term. If the last term is positive, like this here, and the middle term is positive, like this here, then you will take the plus plus solution. If the last term is positive and the middle term is negative, then you'll take the minus minus solution, which is here. Now, these are things that you're not supposed to actually think about, because you have to think about it logically. Last term is positive, but the middle term is negative. Then you have to have a minus minus, because if you add a plus will be a positive. We can add that right here. See, plus plus a plus will equal to a plus. Gives you a middle term. Minus plus a minus equals to a minus. You cannot have a plus plus a plus will give you a minus. Impossible. Think about that logically. Let's look at the second one. If the last term is negative, which is what we have here, the middle term is negative, which is what we have here, then you'll have the case where the bigger number will be negative, smaller number will be positive. If the last term is negative, which is what we have here, and the middle term is positive, which is what we have here, then the bigger one will be positive and the smaller one will be negative. I've already explained that in detail. And that is how you solve trinomials with the highest degree of 2 and the leading coefficient of 1. Right? Now, what we'll do is we'll work with tons of examples and we will just emphasize these ideas. Okay, so now let's work with a few examples. Let's say that you're given x squared plus 3x plus 2. We see that the last term is positive, so therefore it's either plus plus or minus minus. Then we look at the middle term and we see it's positive, so therefore it has to only be plus plus. Since 2 is a prime number, it can only be 1 and 2, so therefore I can confidently put x plus 1, x plus 2. Very simple. Next example, x squared plus 3x minus 18, right? We look at the last term. The last term is negative. So therefore, we'll have a minus plus or a plus minus. Since the middle term is positive, then the bigger number will take the plus. So if we look at 18, 18 is 1 and 18, 2 times 9, 3 times 6. Just by looking at this, I can see that the middle term is 3. So therefore, we're looking at more at 6 and 3, right? Because if you subtract them, they should give you that 3 in the middle. So therefore, it'll be x, and the bigger number will take the plus. So it'll be x plus 6, x minus 3, right? You can go and test it. You can follow the rules to the T, but I'm showing you by working faster and using more creative techniques, you can see how we can get to the answer quicker, right? So the product, we know it has to be, since we have a negative last term, it has to be a plus and a minus, but since the middle term is positive, the bigger number has to take the positive and the smaller number has to take the negative. Let's say we're given this example, x squared plus 11x plus 24, right? I listed out the factors. I can solve this mentally, but sometimes it's nice to list out the factors, especially at grade 9 when you're still being introduced to this topic. So we have the last term as a positive, so therefore the terms in the brackets or the outer terms of the binomials have to be either plus plus or a minus minus. Since we have a middle term that is positive, it has to be a plus plus. 1 plus 24 is 25, 2 plus 12 is 14, 3 plus 8 is 11. So therefore it will be x plus 3, x plus 8. Simple. We got x squared plus x minus 6. Right, 6 can be broken down into 1 times 6, 2 times 3. We have a last term that is negative, but a middle term that is positive. So the last term is negative, will be a minus plus or a plus minus. Since the middle term is positive, the bigger number takes the plus. So therefore it will be this one, plus 3 minus 2. Right? Right, so if you want to do the long method here, if you want to do the long method, we know that it has to be plus minus. The bigger takes the plus, the smaller takes the minus. So therefore it will be minus 1 plus 6 is what? Plus 5. So therefore this cannot be a solution. But minus 2 plus 3 is the solution. But I'm just skipping all of that steps. But if you want to be mechanical, you can't, right? I'm just showing you how to get to the answer quicker by not actually going through each factor. Because sometimes you could have a list of factors, you just need to be quick. That's why mental maths is so important. Let's say that we have x squared minus 4x plus 3. Right? 3 is a prime number. The last term is positive, so it'll either be plus plus or minus minus. But since the middle term is negative, it has to be minus minus. So very simple. X minus 1, x minus 3. Very simple. You could have x squared plus 4x minus 5. Last term is negative, so you'll either have a plus minus or a minus plus. But since the middle term is positive, the bigger number takes the positive. So it'll be x plus 5, x minus 1. Right? You need to get quick at doing this. Let's say that we have x squared minus 2x minus 35. Right? Now, you see also what's another clue here, and this is what I want you to start thinking about. You see when the middle term is small, it's a very small middle term. You're generally going to take the factors that are more at the bottom. So let's say, see, it'll be 1 times 35, 2 no, 3 no, 4 no, 5. 5 times 7. You're generally going to take the factors that are lower because when you subtract or you add them, it'll give you the middle term. But when you have a middle term that is large, then you'll take factors at the top. Right, so let me explain this. Let me elaborate on this idea. So you have a negative last term. So it'll be plus minus or a minus plus. But since the middle term is negative, the bigger number will take the negative. So it'll be x minus 7, x plus 5. And that's how you get the answer. But let's say we were given x squared. Let's say we were given x squared minus 34x minus 35. Then you can see, since you're dealing with a big middle term, then you're going to take the factors that are more at the top. See, like here, for example, I took the factors that were right at the bottom because I'm dealing with a small middle term. But if it was a bigger middle term, I would be more at the top here, at the higher numbers. I hope you understand that it's just like another trick that you can use. So here you can see we have a negative last term and a negative middle term. So negative last term means minus plus or a plus minus, but the negative has to go on what? On the bigger number. So therefore it will be minus 35 plus 1. Right? So you see, these are things that you will notice when you repeatedly do tons of questions. You will see these things happen. But if you do not work with enough questions, you're not going to get better at it. And sometimes you're just going to waste a lot of time writing or listing all of these factors. Right? So I'm just saying, right? Ideally, the ideal scenario would be where you would look at the last term, right? You would have the factors in your mind. You'd look at the middle term and you say, you know what, this is in fact a very small middle term. So therefore, you'll just, in your mind, you'll jump straight to the last set of factors. If you, provided that you're listing them out in this order, 1, 2, 3, 4, whatever. Right? Remember, as I said in the HCF video, think of the first few natural numbers and then start working like that. Right? Very, very simple idea. Very simple idea. Now let's work with a bit more complicated examples. Let's say that we were given x squared minus 6x minus 2x plus 12. Here we have to simplify this by saying that we have two like terms. So it'll be x squared minus 8x plus 12. This will be x and x right? 12, you get 1 times 12, 2 times 6, 3 times 4. We're going to be playing somewhere here, right? We have 12, we have a positive last term, so it'll either be a plus plus or a minus minus, but since we have a negative middle term, it has to be minus minus. Minus 2, minus 6. Let's say that we have d into d minus 5 minus 84. Very simple. This will be d squared minus 5d minus 84. See, now look here. Very small middle term, very large outer term. So you're going to deal more with factors that will be right at the bottom. But if you want to list it out, it'll be 1 times 84, 2 times 42, 3 times 8, 28, 4 times 21, 5, 6, it'll be 6 times 14, 7 times 12, 8, 9. Right, so remember the technique I told you. Think of the first few natural numbers. Once you see a factor repeats itself, like when you get to 12, it'll say 12 times 7. You already see it there. That's when you know you need to stop. Right, I've already talked about that extensively. See, again, very small middle term. I'm going to deal with more of the factors at the bottom. So this is how you can start isolating. Think of the top half, bottom half. You're going to most likely be at the bottom half. Right? So therefore, you'll have two brackets D and D here. You have a negative last term, so it'll be a plus minus. And since you have a negative middle term, then the minus will go on the bigger number. So it'll be minus 12 plus 7. And minus 12 plus 7 gives you a minus 5. Now it's very important to remember that whenever you do these examples, you must always distribute back into the brackets and check if your answer is correct. Right? See, d times d is d squared. Plus 7d, see, this is how you do it. Plus 7d minus 12d gives you minus 5d. Minus 12 times 7 will give you minus 84. That's how I know my answer is correct. Right? Please check. Be very intentional. Don't just distribute and look here and say, you're not okay. Yeah, in fact, we do have the answers. Check. Put it in your calculator and double check. Right? Okay, so let's have a look at this example here. Very interesting example. Firstly, we can see that we have the squaring of a binomial, or we're multiplying two binomials, two identical binomials. So therefore, we have to utilize the SMS rule, where we square the first term, we multiply the first term by the second term by 2, and we square the last term. So let's do that. So it'll be 2x squared. Remember here, we have to follow BODMAS, work with the brackets first. So therefore, we'll have x squared plus 6x plus 9 plus 18. Still BODMAS, focus on the brackets. 2x squared minus x squared minus 6x minus 9 plus 18. Then we can add like terms. 2x squared minus 2x squared is x squared minus 6x minus 9 plus 18 is plus 9. List the factors of 9. 1 times 9, 3 times 3. Since we have a positive last term, then we must either have a plus plus or a minus minus in the bracket. But since the middle term is negative, we have to have a minus minus. It'll be minus 3, minus 3. And that's basically how you solve this example. Very simple, very simple idea. But you can see how we can start merging the ideas of products in here and test our understanding of products as well in factorization examples. Okay.